Hello again. And we are back talking about parallel and perpendicular lines. This video is going to cover an application problem. It's kind of an application problem. It's kind of just a combination problem with all of the individual concepts that we've learned so far about writing equations of lines, graphing them, writing an equation of a parallel and perpendicular line, and graphing them. Okay, this problem is very important. You will actually see this type of problem on your exam, your final and your benchmark. So this is an important problem for you to take a close look at and to practice. All right. So it says a line contains a pair of points. Okay, well, we're familiar with that. Remember, when we are asked to write an equation, right, we either need the graph to look at, we need a scenario where we have the slope and they give us a point so we can find b, or they give us 2 points, in which case we can find our slope and our b from that information. All right, and we notice that we're supposed to put them into slope-intercept form. So as a reminder, our slope-intercept form is y is equal to mx plus b. We know our job is to find both of these values. Okay, so with 2 points, remember that we're just going to find, so our m, in order to find our m, I should say, we're just looking at the difference between our y coordinates divided by the difference between our x coordinates. I'm going to randomly label these 0.1 and 0.2 just so I'm consistent. And I'll start with 0.2. So my y on my 0.2 is 4 minus my y coordinate on 0.1, which is 1. Since I started with the second y, I have to start with the second x. That's going to give me 3/6, and I always simplify, so I'm going to have a slope of 1/2. Okay, so that's the first part of it, and of course now we need to find our b. And in order to find our b, remember that we just choose one of those points to plug in, right? So let me change this here. So we're going to take our original, this is our original equation here, and we're just going to plug in those the points. Now I'm going to just use the simple point here. This is the original point. This is the most simple. It's got smallest numbers. So I'm going to say 1 is equal to, and I'm going to use my slope that I just found. 1 is equal to 1/2, and then I'm going to multiply that by my x. So I'm going to multiply that by 3/1 plus b. Now you notice everything is a number except for b, so then I can solve for that. So 1 is equal to 3/2 plus b. I'm going to minus 3/2 and minus 3/2. Okay, let's move this direction. Should just do this. Let's come up here. All right, so we've got 1 minus 3/2 is equal to b. Now we know we've got a fraction problem here. We need common denominators, so we can just call this 1 2/2. We know that 2 divided by 2 is 1. We need a common denominator of 2, so that'll do it. 2 minus 3 is going to give us a -1, so our b is going to be a -1/2. Okay, so our new equation, if we put all of this together, all of this information together, is going to be y is equal to 1/2 x minus 1/2. This is the equation for our original line that contains both of the given points. All right, so B is going to ask for the x-intercept as an ordered pair. Remember, an ordered pair just means an x and a y. That's all it means. We put in parentheses, x and our y. So it's asking for the x-intercept and it's asking for the y-intercept also as an ordered pair. So our x-intercept, remember that when we're finding our x-intercept, it's where that line crosses the x. At that spot, y is equal to 0. On our y-intercept, our x is equal to 0. So we just kind of shift those or flip those or whatever you want to say. All right, so let's go ahead and write the equation down here. We've got y is equal to 1/2 x minus 1/2. Not a lot of room here, is there? Okay. Now we're going to just plug in a 0. So we're going to say now that 0 is equal to 1/2 x minus 1/2. We'll go ahead and add 1/2 to bring it over to the left. So now we've got 1/2 is equal to 1/2 x. Now, if we were to look at this in terms of fraction busters, we can see both of the denominators are the same, right? So I'm going to do this two ways. We've had some practice with fraction busters. We can cross those denominators out. They're both the same on both sides. Every term has the same denominator, so we can literally cross them out. And 1 is equal to 1x or x, so we're already where we need to be. But if you're not, excuse me, if you're not comfortable with fraction busters quite yet, we can look at this in just a teeny bit different way. Remember that in order to get rid of a fraction over here, we would just multiply by its reciprocal. So we would say this is going to be times 2/1. Okay, that's going to give me 2/2, so that's gone. And times 2/1 here, we can see, oh, well, I'm there again. So the answer to B is going to be an ordered pair where x is 1 and y is 0. So this is my answer for B. Now for the y-intercept, okay, the easiest way to look at that, guys, is to remember that my y-intercept is already in my equation. It's right there, right? So we could just jump right to the answer. We know that x is 0 at the y-intercept, so we could just jump right there. And I would suggest if you can do that, do it. If you wanted to do the math of it, you would just write out your equation. 1/2, and your x, of course, is 0, minus 1/2. And you can see right away that 0 times anything is going to be 0. So we would have gotten to the fact that y is equal to -1/2 when x is 0 anyway, and that gives us our intercept. That is our point for our intercept. Now, this is nice. We have our intercepts for this line, because then in D it asks us just to graph that line. So we can just graph the intercepts. So we're going to go 1 at 1, 0, 1, 0, and 0, -1/2. So this is going to be so close together and a little bit hard to deal with. I would suggest when you have something like this, I mean, if we were to just, draw a line through here, you can see it may not be super exact. So I would recommend, I'm going to go put these back again, 1, 0, and 0, -, oops, what happened there? 0, -1/2. I would suggest to go back to your original equation, remind yourself of what your slope is. Your slope is 1/2, and so you can actually plot several other points. If your slope is 1/2, it means we rise 1 and we run 2. We rise 1 and we run 2. We can also go the other direction. From 1/2, if we go down, right? So it's a positive slope. So let me just remind you here for this positive slope. I'll actually write it here and I can erase that. If we have a 1/2, that's that's the same as having a -1 over a -2, right? Negative divided by negative is a positive. So I could go down here to my -1.5, that's down 1, and then negative on my run 2. Down another one and negative, right? Down another one and negative. If I wanted several points there, I could plot them, which helps to make my line a lot more accurate when I'm connecting these points. Okay, of course it doesn't have to be exact, but just giving you some ideas there. All right, and we often try, anyway, to label the points, or the lines, excuse me. So I'm going to call this, oh my goodness, Andrea. All right, y is equal to 1/2 x minus 1/2. All right, now let's go ahead and jump to E here. Our job is to find an equation of a second line that is parallel to this line that we just graphed, and it passes through 0, 3. So you notice they're giving us information, giving us everything that we need to do this, because we know something about a parallel slope, don't we? We know that a parallel line has the same slope as the original. And here is an x and a y that is on that new line that we're supposed to come up with. And we are also supposed to graph this on the same grid when we're done. All right, so let's get right to it. We have our same slope. We know that our slope is also, in this particular example, 1/2, right? That was what you notice down here, 1/2 on our graph there. So we're going to have y is equal to 1/2 x plus b. Okay, and then we can go to the point that's given over here, and we can plug in our x and our y into these positions right there. All right, so let's do that. So we're going to have 3 is equal to 1/2, and we've got 0 for x plus b. So we have b is equal to 3. B is equal to 3. All right, well, how about we put all of that together? I think I'll make this line a pink one. So this is our m, this is our b. Let's put it together. Y is equal to 1/2 x plus 3. Okay, so this is our parallel line. And let's go down and graph that. Now you notice we don't have the intercepts here, but we have the equation. And I really like graphing a line from the equation. You guys can make a t-table if you need to. You can find the intercepts if you feel better about graphing by intercepts, or you can just use the equation here. Remember, when we do that, we plot the b. Okay, so we're going to plot our 3 right on the y-intercept here. And then we just use our slope to find another point or another couple points. And the same, we talked about this a minute ago. If our slope is 1/2, they can both be positive or they can both be negative. Go in a negative direction, it's still the same. So we can go up 1 over 2, up 1 over 2, positive direction, or down on the y and negative on our x, down on our y, negative on our x, and so forth. And we can see that all of those points are definitely in line with each other. And then we're just going to connect those. And we'll label this guy. Okay, so far that's looking good because we know those lines should be parallel and they look like they're parallel. All right, let's go down to F. Let's choose a different color here. How about that? Find the equation of a third line, this time that is perpendicular to that line, and passes through to -9. Okay, well, we definitely know something about perpendicular lines, right? We know that our slope has to be the opposite sign or the opposite reciprocal. Okay, it just really means the flip of that line. So it's a little hard to see. I'm going to go back to black. So if our original m is equal to 1/2, it means that our new m, or our perpendicular m, is going to be the flip of that, which is going to be 2/1, and it's going to be a negative, right? So I'm going to just leave it at -2. If I wanted to graph it, though, I could put that over 1. Doesn't really matter. Okay, so here is our new m. And of course, once again, to find b, we always just plug in the point that's given. So y is equal to -2. We know that's our new slope, x plus b. And let's plug in our new point, or our point here. We've got a -9 for our y, and we have a 2 for our x. -9 is equal to -4 plus b. Let's get rid of that 4 and move it over. So we've got -5 is equal to our b. Therefore, when we put all of this together to answer the question, our new equation is going to be y is equal to -2x minus 5. Okay, so let's graph that. Make sure it looks the way it's supposed to. All right, remember, we go down to our y-intercept and plot our point. There's our point, and we're using our slope, -2/1. So I want to remind you, once again, we're just kind of playing with this idea of using our slope to graph. So we can go down on our y2, but then have a +1 on our run or on our x, or we can do vice versa, right? Those are the same. They're both still a negative slope. So I'm going to choose this version because I'm already way down here at -5 on my y. I kind of want to go up. So I'm going to go up 2 on my y, but a -1 on my x. I'm going to do that again. And again. And maybe one more time. Just so I've got enough points that I can see really clearly and I can connect them. I always want to extend my line out. And I'm going to label that -2x minus 5. Okay, and we're super happy about that because we can go back and take a look at whether or not these look perpendicular, and they definitely look like they cross there at that 90-degree angle. All right, guys, so like I said, this problem is very, very important. Please practice this, and you will see this type of problem on your benchmark as well as on your final exam. If any of you feel like you need more practice on these types of problems, please let me know because I do have some practice versions basically of this same problem. All right, thank you, and we'll talk to you soon.